SAS demonstration video, Creating New Variables. For this demonstration, we are going to use the Owen dataset to demonstrate how we can create new variables in SAS. So once again, we are going to be reading in 1006 observations, and we are going to recode missing values with SAS missing value periods. And then we're going to start to look at some examples of how we can create new variables using if-then statements. So we're going to create new variables with what we call an indirect assignment. In the first example, I want to recode mother's age into 6 categories, each category representing every 5 years. And I'm calling the first variable I'm creating wrong age. The reason I'm calling it wrong age is because this is an incorrect way to recode mother's age. And the reason is in this very first statement. If mod age is less than 20, then wrong age equals 1. The problem here is that if an observation is missing for mother's age, then that observation is going to be recategorized into wrong age equals 1. It's going to be as if the mother's age was less than 20, when actually the mother's age is missing for that particular observation. And then we go on and we say, okay, if mother's age is greater than or equal to 20 and mother's age is less than 25, then wrong age equals 2. So we're going to capture all women who are between the age of 20 and less than 25 and call that group wrong age equals 2. And then for the next 5 years, we're going to say that if wrong age is greater than or equal to 25 and mother's age is less than 30, then wrong age equals 3. And finally, in our last category, we're saying that if mother's age is greater than or equal to 40, then wrong age equals 6. So we've created a variable called wrong age, which takes on the values 1 through 6. Here is an example of a correct way to recode mother's age. And we're going to call this new variable age group. And so notice here we're saying that if mother's age is greater than or equal to 0, so it has some value, either 0 or more, and it's less than 20, so it's somewhere between 0 and 20, then age group equals 1. If the value of mod age is somewhere between 20 and 25, then age group equals 2. And all the way down till if the value is somewhere greater than or equal to 40, then age group equals 6. So when we create the variable age group, if that observation is missing for mod age, it's not going to be classified at all. So if mod age is missing, then age group is going to end up being missing. And there are a number of ways that you can correctly recategorize a variable. I'm just showing several different ways here. Here's another way. We could correctly recode mother's age. We could say that if mod age is not equal to missing and mod age is less than 20, then age group 1 equals 1. So here we're saying that for that observation, it can't be missing and it's less than 20, then we're going to classify that observation as age group 1 equals 1. And then we have similar coding that we've seen in these other examples. So we've created 3 different variables for the recode of mod age. And when we look at the frequencies, we'll begin to understand why wrong age is an incorrect way of recoding mother's age, whereas age group and age group 1 are correct ways of recoding mother's age. The other thing I want to point out is that, as I showed in the video on how we do formats and labels, we can actually use a format statement to recode a variable, but this will only be for display purposes. We're not actually creating a new variable, we're just using a format so that the continuous variable would be displayed as categories. Now let's take a look at how we could recode socioeconomic status into 2 levels from its original 4 levels. So there are 3 different ways, and they're all equivalent, They all produce the same results of how we could do this recoding. So the first way, we're saying that if W rank is less than or equal to 2 and W rank is not equal to missing, then socio-econ 1 equals 1. Else, if W rank is greater than 2, then socio-econ 1 equals 2. So again, we're taking care of the fact that if we had a missing value for W rank, it wouldn't be recoded as socio-econ 1 equals 1. Another way we could recode this is with the in function, and this is a special function in SAS. And so we're saying that if W rank in 1, 2, so if the values of W rank are 1 or 2, then we're going to create a new variable called socio-econ 2 equals 1. Else, if W rank in 3, 4, so if W rank has the values of 3 or 4, then socio-econ 2 equals 2. So this is a second way that we could recode W rank into 2 levels. The third way is with a select statement. So the select statement begins with the word select, and it creates a select group. And so here we're saying select W rank. So we're selecting the variable W rank. When 1, 2, so when W rank equals 1 or 2, we're going to recode it as a 1. So we're going to create a variable called socio-econ 3 equals 1. When W rank is 3, 4, we're going to categorize socio-econ 3 as equal to 2. Otherwise, it's going to be missing. If you were missing for W rank, you would then be missing for socio-econ 3. And then this last example is showing how we can create a dichotomous or dummy variable for birth weight less than 2,500 grams. Birth weight was originally recorded in tens of grams. So the first thing we're going to do is we're going to use a formula to change birth weight into grams. So we're going to say B weight equals 10 times B weight. So we've now converted it from tens of grams to grams. And then we're going to say if birth weight is greater than 0 and birth weight is less than 2,500, then low birth weight equals 1. If birth weight is greater than or equal to 2,500, then low birth weight equals 0. And notice that it's very important that we have the greater than or equal. Let's say if you had written this statement, if birth weight greater than 0 and birth weight less than 2,500, then low birth weight equals 1. And if birth weight greater than 2,500, then low birth weight equals 0, you would have missed babies who had the birth weight of 2,500. So you want to make sure that you encompass all of the possible birth weights when you're doing this recategorization. So let's take a look. There was a lot of code that was presented here. And let's run all of this code and see what our output looks like. Okay, so I'm going to page up to the beginning. So here we're going to start out with a proc means of mother's age, MOT age. Notice that there are only 981 subjects where mother's age was recorded. But when we created this new variable, wrong age, 1,006 observations had a value for wrong age, some value of 1 to 6. So the problem is that when we did that recoding of wrong age, we collapsed the missing values into the first category, wrong age equals 1. So if we page down, we see here that when we did the recoding of wrong age, we had 47 of our observations classified with mother's age being less than 20, when actually only 22 of our observations had mother's age less than 20, or age group equals 1. And so there should have been 25 observations that were missing for this newly created variable, where we used MOT age as the variable that we were going to do our reclassifying from. Here you see that when we did this second way of recategorizing mother's age, it also came out correctly. The frequency missing was 25. And notice in this last example where we actually attached the format to mot age. So this is our original variable, but we're attaching a format called A group. It also shows that the appropriate number of observations that were missing mot age are shown in our frequency distribution. So again, it's very important that when we create a new variable that the distribution matches the original numbers of observations that variable had shown up for. Here we see that suddenly 1,006 observations have a coding for wrong age, whereas in actuality only 981 or 25 less subjects had the variable mot age entered. Now here is our recoding of W rank or socioeconomic rank. So this was the original coding. It took on 4 levels. Notice every observation had some kind of socioeconomic class entered for that variable. And then in our new variable, we were collapsing 1 and 2 into the first category and 3 and 4 into the second category. And each of the different ways that we recategorized socioeconomic class came out appropriately. We expected 643 to be classified as 1 based on W ranks 1 and 2. We expected 363 to be reclassified as 2 based on the levels 3 and 4 of W rank. And we looked at 3 different ways in our code of regrouping W rank into a dichotomous variable. And then in our last example, we took the variable birth weight, we converted it first to grams, and then we categorized it into 2 levels, where 0 equals normal weight and 1 equals low birth weight. And so 0, we wanted normal weight to be greater than or equal to 2,500. So you see that our minimum is 2,500 and our maximum is 5,440 grams. The low birth weight babies had a minimum of 910 grams all the way to a maximum of 2,490 grams. So again, this is just a way of checking that the way we categorize our variables, if we looked at the descriptive statistics, were appropriate. So kind of just going back over the code one last time, here I am showing you an example of how to incorrectly recode mother's age, where we don't consider the fact that some of the observations were missing for mot age. I gave you 2 different ways of correctly recoding mother's age. Then I showed 3 different ways to take the variable W rank or socioeconomic status, which was 4 levels, and creating a new variable that had only 2 levels. So here were 3 different appropriate ways to do that recoding. And finally, I'm showing you how we took birth weight. First we converted it to grams and then recoded it into 2 levels representing low birth weight and normal birth weight. This completes the SAS demonstration video on creating new variables.